Now, as we have discussed about how series and parallel circuits of resistors work, let's discuss a numerical. Okay, in this numerical, I have these battery of 12 volts. Here we have resistor 6 ohms and 12 ohms, and here we have resistor such combination, and this time let's assume values 2 ohms, 4 ohms, 6 ohms. Okay, and this is connected with an ammeter. The question is, what is the reading in ammeter? Now, question is very clear. We want the reading in ammeter, that means we want to know the value of current flowing in the circuit, right? But after this numerical, I'll take you to advanced level how to solve further type of numericals. Let's see. First of all, I can simplify this circuit by taking these two resistors in parallel and these two resistors in parallel. Okay, so what would be the parallel combination of 6 and 12? It would be 1 upon R is equal to 1 upon R1 plus 1 upon R2, right? This is the formula I'll be using. So 1 upon 6 plus 1 upon 12. This gives me 1 upon, not 1 upon, this gives me 12, and over here I'll get 2 plus 1, right? So this gives me 3 over 12, so that is 1 by 4. Now many students always do this mistake that they forget to reciprocate the final answer, because the combination of resistor is not 1 upon 4, because 1 upon 4 is equal to 1 upon R. The combination is actually equal to 4, right? So 6 and 12 ohms in parallel gives you 4. Don't forget to note that this step is very crucial. Students actually do this mistake. They forget to reciprocate it. Don't forget that. Okay. Now, the combination or the net result of this is 4 ohms. And for this 2, 4 and 6, I'll use the same formula. So 1 upon R would be equal to 1 upon 2 plus 1 upon 4 plus 1 upon 6. Going to give me, LCM would be 2, 4, 6 would be 12 only, not 8. So 6 plus 4 into 3 is 12 plus 6 into 2 is 12. So this is giving me 6, 7, 8, 9, 10, 11 upon 12, which is equal to 1 upon R. This implies R is equal to 12 upon 11 ohms. This is the value of resistance for this combination, right? Okay. So now what we are doing, I've got the values, which is this. For one part I have 4 ohms, and for one part I have 11 upon 12 ohms. Sorry, 12 upon 11 ohms, right? Let me write it down. This is 12 upon 11 ohms. So this circuit can be redrawn like this. One resistor, then the battery, then another resistor, and our ammeter, right? So this is 4 ohms, this is 12 upon 11 ohms, 12 upon 11 ohms, and the current is flowing like this, because we always take the conventional direction, which is from positive to negative, right? Okay, now I want the value of current flowing in this circuit. For that I still have to solve it further, because we know that V is equal to IR. I can find out the value of I if I have the value of V and I have the value of R. But right now I have the value of V only, which is 12 volt, right? But I don't have the value of R, because R is the total final resistance of the combination of all the resistors which are used in the circuit. I have two resistors, 4 and 12. Are they connected in series in this circuit? Yes. So 4 and 12 are 4 and this resistor, they are in series right now because they are in the same line. If both the ends are connected with same common beginning and same common start, I could have said that they are in parallel, but right now they form a single loop. There is no other direction of flow of current. That means they are in series. See, simplest way to know if the resistors are in series or not is that if same amount of current flows through both the resistors or n number of resistors, that means they are in series. This current, whatever it is flowing, the same current is flowing through both 4 and 12. When current is same, resistors are in series. So net resistors would be 4 plus 12 upon 11. This gives you what? 11 into 4 is 44 plus 12 upon 11. This gives me 56 upon 11 ohms. So this is the total combination of resistance, which is 56 upon 11. So I can again redraw this circuit like this. I have my battery and then resistor and then the ammeter. Okay, so from here you can see 12 volt, this is 56 upon 11, right, and ammeter. So now you can see that we have V and we have R. So from this formula I can find out the value of current, which is V upon R. What is V? 12 upon what is R? 56 upon 11. So this gives me 12 into 11 upon 56 amperes. Now sort it out. 4 into 3, 4, 1, 1, 16, 14. So I cannot solve it any further. So it is 33 upon 14 amperes. You can leave it this way, or if you want to write it into decimals, so it will be 2.14 into 2 is 28. We have a leftover of 3, no, not 3, 5. So 5, 0, 50. 14 into 5 is more, so it will be 4 or 3. 50 into 3 is 45, so it will be 3. So 12.3 amperes, 2.3 amperes. This is how you solve these kind of questions, by actually combining all the resistors which are taken in series and parallel, and then you apply this formula. Let's do one more equation.